So hello everyone. In the last lecture, we were discussing about different type of shifts occurring in the UV band, and then we saw that sometimes the wavelength can be increased, can be decreased, and sometimes you observe the increase and decrease in the energy of the absorption, intensity of the absorption. So we took so many examples related to that, but what could be the reason behind it? That is what we are going to discuss in this lecture. I am going to focus more on factors which combinedly affect the UV band. So there are major factors which you have to look into before calculating the absorption maximum or calculating the wavelength for a particular compound. As written here, you can see that the very first factor is conjugation. Conjugation is extremely responsible for this kind of shift. I hope you understand the meaning of conjugation is nothing but alternate single and double bonds. So when you increase the double bond, what happens is the energy between the transition of pi to pi star, here you can see the energy. If I increase the number of double bond, the energy decreases. And now since you know that energy is inversely proportional to lambda, that means if energy is increasing or decreasing, it is going to affect the wavelength. So here if it is energy is decreased, wavelength is increased. So that is how you are going to observe a bathochromic shift, that is increase in the wavelength. So you have to interpret the result in this manner, that what effect this particular compound is making on the energy level diagram. If you go by second steric hindrance, then also you have to find out whether too much of the functional group is occupied there. Is it losing the coplanarity? If it is that, how is going to affect it, whether it's going to decrease the wavelength or increase. Similarly, solvent do play a very important role. If it is a polar solvent, then it is going to affect N to pi star transition. And if it is non-polar solvent, then also you have to see whether there is a possibility of hydrogen bond or not, etc, etc. Similarly, when you go with the pH of the solution, like in the right hand side here, you can see the nature of phenol. So here you can see that if it is in base solution, you can see the difference in the wavelength. In the basic condition, oxygen is available for resonance. That is how there is extension of conjugation. So that you have to see whether it is basic or acidic solution. So what is the pH? Likewise, temperature, well, it does not have that much of the difference, but at very low temperature, UV spectrum come as a fine line, not a pad, and so as the concentration of the solution. So I'm looking forward for this lecture, and let us discuss each and every factor in detail in the coming lecture. Thank you.